Hello world, Decentralized David here, and I'm sending best wishes out to everyone watching this video. Today I'm starting a new series of videos which will give you a solid understanding of blockchain technologies, so be sure to subscribe to this YouTube channel so you'll be notified when the next videos are posted. In this video I'm going to give you an introduction to how blockchains work. So blockchains in their most simple form are ledgers. And what is a ledger? Well, a ledger tracks accounts and balances. Basically, all ledgers as we know today are centralized, like the ones used in banks. Blockchains enable a new concept called distributed ledgers. So, a little unknown fact to most people, the Bitcoin white paper presented a mathematical breakthrough in consensus algorithms. This is what enables blockchains to become functional in production environments now. So cryptographic technology enables a ledger to be securely distributed across geographic locations. In terms of distribution, the Ethereum network consists of 20,000 nodes across the globe. Other enterprise ledgers implementations may only consist of, say, a few dozen or possibly a few hundred nodes spread across a few countries or continents potentially. Consensus algorithms are critical for blockchain security. The consensus algorithm is implemented in the node client software, and this mechanism determines the rules to which a system agrees upon state changes, such as updating account balances after a transaction or the state of a smart contract after execution. There are multiple ways to implement consensus algorithms. Today, the most popular method is proof of work. This is used by the Bitcoin and Ethereum public blockchains. The Byzantine generals problem is interesting, and it correlates directly with how blockchain consensus algorithms function. Think of an army surrounding a castle. The next step is communication to decide whether or not to proceed forward with the attack or to retreat. If only half the army were to receive the message to attack and the other half of the army was to not receive a message or agree to retreat, this would be very bad because half of the army would basically disappear from the battlefield. Now think of this situation in terms of hundreds or thousands of blockchain nodes, and they're trying to agree upon the state of an account balance. So these problems are very similar. So blockchain consensus mechanisms today can handle 33% of the nodes being in a compromised or reporting a dishonest state. Once 2/3 of the network agrees upon the state, consensus can happen, and the network can continue to move forward processing the next set of transactions. In a proof-of-work consensus system, miners compute complex mathematical hashes, trying to guess the next ones to be used in the blockchain hash sequence. Once the next good hash has been found, the miner is rewarded in the form of cryptocurrency. This reward is rewarded for performing the mathematical compute work that the miner did. Proof of work unfortunately uses a lot of compute power to find the next hash, and it's typically slow for public blockchains. The Ethereum blockchain on average creates a new block every 15 seconds due to the compute overhead required to find the next block. I hope you enjoyed this video, and please let me know if you have any questions below in the comments, and be sure to subscribe so you're notified on the next video that I release. I'm also releasing a set of videos on how to build blockchain applications, so be sure and check them out as well. Cheers!